Yeah, my name is Sunil Kumar Jang Bahadur. As already introduced, I'm working as a customer engineer. I'm working as a AI ML specialist as well as a generative AI specialist in India region. So obviously today's agenda we'll start with the foundation of DevOps as a base of our ML ops perspective. And then we'll look at the spectrum of portability because that is most important when you're working on the any ML solution, right? And that's the whole agenda of our topic, how we can make our ML model portable. And then we'll see how Google does it, a quick demo, which will more like any developer do, right? Hello world kind of a demo. In this, we'll do hello next 24. Then some parting thoughts and key takeaways from this session. If you have any question, feel free to raise your hand, or maybe at the end, I'm happy to take that question offline as well. So obviously, this is the CI/CD pipeline look like for any dev application. You have the develop, then test and deploy, and then repeat, right? But that is not sufficient for the ML workflow that currently we are operating on, and the kind of scale the technology is progressing, the pace at which we have to deploy the use case in the production. So from that perspective, obviously there is additional element that is required. One is continuous training, and second is continuous monitoring. You will say that monitoring we are already doing for other dev application as well, but in ML space that is different. In ML space, obviously once you build a model that is being trained on the particular training data set, and when you put it into production, there might be chances that there is a drift in the training data set, due to which the production data and training data has a mismatch. So it's not performing well actually in the production. Second case is you have deployed that model, but over the period of time, the model accuracy has drifted, because of which you are getting the low accuracy. So because of that, we need this kind of continuous monitoring. And because of this continuous monitoring, based on that, you can trigger a continuous training to further enhance the model, further improve that model, either correct the training data set, maybe the training data set is not relevant right now for the recent trend of the production environment in which you are trying to deploy those models. So that corrective action, you get a flexibility to do that. Even when you are training that model continuously, you don't have to do that continuously. You can monitor the performance of your model in production and take a conscious decision whether you want to further train that model or not. It should not be a scheduled task that, okay, every month, every hour, you are training that model repetitively, right? So that basically can be used as a feedback here to train your models. And that's what the continuous training will help. And from the monitoring perspective, I think I discussed that there are two elements. One is the training data skew, and second is the production drift. So training data skew is where there is a mismatch between the training data and the production data, and second is over the period of time, there is a drift in the performance of the production. So how do we keep up? For that particular thing, we need a pipeline so that you can automate the complete steps. So pipeline is nothing but you're automating the every steps of that particular process so that you can trigger it autonomously and automate that so that that can be triggered periodically or a particular event. So that's called basically a pipeline where you are executing the small blocks of each actions that needs to be performed in ML ops and taking based on the success of that step, taking the next step, and that's basically the pipeline. So there are two approaches. One is the managed service, which is a Vertex AI, and second is open source, which is a Kubeflow. So Kubeflow is open source framework. So there are two choices or multiple choices as well, but we will focus on these two right now. So one is basically a managed service. So decision has to be made whether you want a managed service or flexibility. In managed service, the complete Vertex AI pipeline is managed, so you don't have to deal with the operation perspective of that particular element, the ops part. Second part is the Kubeflow, where you get a flexibility. You can run that anywhere, any environment, your local environment, your desktop, your server, or maybe in different cloud providers, right? So that basically gives you a flexibility, but you have to handle the ops part. So obviously in this particular session, we'll see how we can make this model and leverage the benefit of both the worlds. How we can make use of managed services and make use of open source frameworks as well, so that the model becomes portable. So maybe not, I'm saying you should do that, but if you want to port to some, let's say some different cloud provider as well, then you can directly take that solution and port it directly. You should not be locked in to a particular cloud provider or particular platform or particular service. And that's we are going to show in this particular session, how we can make this complete pipeline portable and how this Kubeflow and the Vertex AI play a role in that. So portability is spectrum. So portability basically means how you can take a model. Obviously, that's the whole point, right? I have created one model, maybe in local ecosystem. I try to deploy in my data center. Maybe over the period of time, I see I want to scale it to a global audience. Then I want to take it to the cloud. So I don't have to keep on changing my tech stack. The tech stack and the code that I have written should be minimally changed so that I can take it wherever I want based on the scalability of solution and the deployment I want and what services I want to use in this particular spectrum. So before we start, there are two major elements when you're working on any MLOps pipeline or want to make the solution portable. First thing is the model framework and second is the pipeline framework. The two things that we have seen is more like a pipeline framework, but the model frameworks you can consider more like a SDK on which you develop your code. And pipeline is more like a CI/CD framework that you want to use. Obviously, framework is not a programming language, but just to give a context, okay, how these two play a role in the portability, the model framework will be more like a SDK and pipeline will be more like a CI/CD framework. So the model framework, choice of model framework also impacts the portability, because if you're using a GPU, TPU or some other accelerator, it completely depends on how easy that model can be ported from one platform to other based on the model framework that you are selecting. So this is the complete like high level model framework where I have listed based on the complexity or orchestration that it provides, right from the higher end to the lower end, that is presented as part of this. So obviously Keras will provide the high level orchestration and the OpenXLA will be more tied to the hardware and like low level orchestration that will be provided at that end. So all the frameworks are supported both on TPUs and GPUs. Obviously, the one question comes to mind, if everyone is not aware of that, the TPU is a tensor processing unit created by a Google Cloud that is primarily meant for training a large language model. And it has an element at the hardware level. It is custom built for machine learning and training of large language model. The hardware is tuned such a way that it can perform large number of repetitive matrix multiplication effectively while processing those model or running those models. So if I look into that, this is the path, like OpenXLA. XLA is basically also called an accelerated linear algebra. That is basically act as a compilation layer for all those frameworks, so which make it compatible with the hardware. So this compilation layer can be used to make it compatible with any hardware, GPU and TPU, and that's being leveraged in TensorFlow and PyTorch as well as JAX. But if you have not used the JAX, is a platform which is built ground up taking into the consideration the XLA framework. So if you're using a JAX, that will give you a best performance and faster model performance, and it will be independent of the hardware accelerator that you are using. So if you want to run it on GPU and TPU, the portability becomes very easy because it has built primarily based on ground up using the XLA framework itself. So one more point around TPU is it basically gives you 2x better performance compared to the leading cloud accelerator that are currently present. So we have different variations of TPU. One is TPU V5E that can be used for training as well as inference both. And second, recently we have announced that TensorFlow or TPU V5P, which is primarily for large model trainings. So second thing that comes to mind is the packaging. So how I want to package the solution. So what comes to everyone's mind when you talk about packaging of any solution? Anyone? Okay. Dockerizing, yeah. So basically you are containerizing that application, right? You containerize. So if anyone is not aware of the container is basically nothing but at high level, I can say it's a virtual machine or a small subset of the virtual machine where the hypervisor are basically used from the system itself. And it comprises of all the dependency that is required to run that solution wherever the Docker environment is present. So after the containerization, you can use the pipeline framework. Primarily, there are two frameworks, or there are multiple pipeline frameworks that can be used that are vendor specific or maybe open source. The two things that I want to highlight or I have used is Kubeflow and Ray. They are popularly used and both are open source. There are a lot of resources as well available for both of them, so that if you are stuck somewhere, you can quickly do the Google search and look into different forum for any help. So that's the reason I think I'm suggesting this too if you want to explore that. And that basically gives you more flexibility to create a solution using these two platforms, and that can be ported to anywhere, because anyways it's open source. You can run on-prem, you want to run on the cloud, you can take that call. And how we do this on Google Cloud? So Vertex AI. Anyone knows about Vertex AI? Okay. So just from the context of larger audience, Vertex AI is ML platform. It's not basically a pipeline framework only, but it's basically a complete ML platform to build end-to-end ML solution, right from data set, data engineering to model deployment, training, as well as AI application development. It supports end-to-end. Even recent announcement of generative AI models are also integrated as part of it. One more solution that we have is a model garden, which is also has the complete Vertex AI pipeline integrated into it. So we'll look into that. What is the Vertex AI pipeline? So this is how the complete spectrum look like on MLOps and Vertex AI. Don't get scared. Obviously, there are a lot of elements here, but the primary focus of this session of portability is around the pipelines. How this pipeline can be created and all the elements that we are seeing can be basically used on or is equivalent to any other cloud provider. So if you have created a pipeline, you can deploy and use the other elements as well from different frameworks as well. It's not necessary it has to be Vertex AI frameworks only or the solutions only. So Vertex AI pipeline basically provides that complete ML workflow or the building blocks of that ML pipeline that needs to be created. So just a high level, just want to quickly walk you through that complete process. How it starts is you have a data set that you have created. What you can do is you do feature engineering on top of it. And once you have feature engineered, obviously if the same data set is being used by multiple teams, you don't want to repeat that process. So we have a feature store where you can store all the learnings that you have acquired from that feature engineering, store in the feature store. That can act as a training data. And as the early development stage, I want to use a notebook or maybe a Colab or Jupyter notebook. So Colab is a Google Cloud product if anyone has used it. In Google Cloud, we have Colab Enterprise as well. So I can experiment it. Once I'm done with my experimentation, I can dump it into the cloud repository where the cloud build will kick in for the CI/CD pipeline. It will create a container, put it in the artifact registry where I can version control my containers. This container will be used for continuous training in Vertex AI, which will be triggered by Vertex AI pipeline. Once that model is generated, I can use the Vertex AI models in the model registry lower here. And for version controlling different versions of model that I have trained, maybe with different hyperparameters, maybe different models that I want to try out. Then again, I can use the same pipeline to create a prediction container, because prediction container will be different from the training container. Obviously, you want to expose the endpoint so that people can call it. You want to add some IAM permission or other elements. So there is a prediction endpoint. And at the end, there will be a monitoring part, which will be used to identify different model performance during production. So obviously, the focus of this session is not to cover the complete MLOps on Vertex AI, but focus will be on the Vertex AI primarily, how this can be used along with the open source Kubeflow framework to make our complete model MLOps journey more portable. So Vertex AI basically has a building blocks. It already provides that. You can use that building block to implement the pipeline. And it is also available as a Python SDK as well as Docker container. You can containerize them as well. Then there are predefined components library that you can reuse and build on top of that. This is complete fully managed service. So there is completely ops part is offloaded to the Vertex AI platform. So you don't have to basically do the ops management, set up a cluster and deploy that, create your own Kubeflow elements. And then compare the pipelines in the UI so that if you are trying different combination and experimenting with different model parameters, model frameworks, or hyperparameters and parameter, maybe different variations in training data, Even every pipeline output can be compared in the UI as well. And last part, it runs on the Kubeflow. So everything that this Vertex AI is built is basically built on top of Kubeflow. So obviously the Kubeflow, what we were discussing is already open source, right? And this is built on Kubeflow. So that means that basically a major factor. So whatever you are building in open source Kubeflow that we have discussed earlier, that Kubeflow or Ray can be used. So if you are building on a pipeline on Kubeflow, the same thing can be run on the Vertex AI pipeline. And if you are trying to use a TensorFlow extensions to build a pipeline, it will also support it there. So instead of directly using a Vertex AI, all the ingredient components, you can create a Kubeflow based pipeline, and that is also compatible with Vertex AI. And then you can run that complete pipeline anywhere, on-prem or and the Vertex AI elements. So we'll see a demo and how that particularly can be deployed. It will be a hello world kind of basic demo, but it will give an idea how the same pipeline created on Kubeflow can be executed seamlessly on Vertex AI as well as your local deployed Kubernetes cluster using Kubeflow UI interface.
One quick question.
Yes, sir.
So you talked about continuous training and continuous monitoring, right?
Right.
Assume that there is a different data. Now, initially you will have the feature set and the training data set,
Right, right.
Now, if there is a drift in the data set or let's assume the drift in the source data set itself.
Right.
Now, will this new data set be used for the training, continuous training, or how was that planned, the continuous training?
See, continuous training, obviously, there are two parts. One is the drift in data and the training data itself. So whatever model you have trained right now does not hold true in the production environment. So obviously, you have to go back to the whiteboard and re-engineer features, gather more data which is relevant to the production endpoint. Second training part will be required when there is a drift in the production deployment. So there is a drift in the production deployment model over the period of time. So there is a new data that is getting gathered. There is a distribution of data has changed over the period of time, maybe because of some other reason. So that all those data that you have captured during previous inferencing, right, or the trends can be used again as defining the new feature store or updating that feature store to basically do the feature engineering on that and include those data set during the training. So
how would you know it's not a seasonal drift?
Seasonal drift. So it completely, see, even if it is seasonal drift, if you want to deploy those models, right, that's where the model versioning will help, right? If you know in this particular season, we see a trend, that's where the data engineering and the data feature engineering basically helps. You get complete data set, identify the trends, and based on that, take a decision based on how corrective action needs to be taken.
So the original data set comes in the field and you revert it back to the...
Yeah, you can revert it back. So maybe I can take this, right? So there are a couple of workflow that is possible. Sorry, so this is a pipeline. Obviously, monitoring, there are two approaches. One, that you can use ML dataset directly to train whatever new dataset that you have trained and do the feature engineering on top of it. If not, that completely, your model is completely off from the production environment, then you can go back to the whiteboard directly, right? Start with the data engineering, explore that data, try to explore different models, how you can better handle it, complete that pipeline, and then deploy the new model. So that will be a completely new model than basically a new version of that existing model. So continuous training is where you want to continuously improve the existing model. But if there is completely drift in the production environment from what you have imagined during training process, then you have to go back to the whiteboard and rethink your strategy, what model will work now with the current production state. Okay. So demo time. So in this particular case, we'll basically run a hello pipeline, hello next 24. So we'll basically see two elements. It is paused. Okay. So in the notebook, what we have done is we have created a Kubeflow pipeline. There are two components that has been used. Nothing major, but we are just trying to print a hello and whatever parameter has been shared. And we will compile that and convert into the YAML file, because YAML file is something that is used in Kubernetes environment. So we'll create that, and then we'll try to use that same YAML file seamlessly in Vertex AI platform as well as the Kubeflow UI platform. How you can deploy both on the UI end as well as the Kubeflow end as well as the Vertex AI end. So if you see this via YAML platform, right? So the YAML file that is being generated is based on the Kubeflow version 2.7 in this particular case. So we'll take this Kubeflow, we'll go to the Vertex AI pipeline, upload that. So it's as simple as uploading a file. So you just upload that and the complete pipeline will get created. And okay. Obviously, in this particular case, there is one stage, but just imagine if you have multiple stages like data exploration, data extraction, maybe training, evaluation, then deployment. All those will be listed as a graph representation. Then you can define the runtime environment. Obviously, in this parameter, what we are passing is next 24, and we'll try to run this pipeline. And same thing we'll try to replicate in the Kubeflow environment using Kubeflow UI. So we'll be using the same YAML file that we have created using the Kubeflow plugin and try to run it. So this, let it run. And then this is a Kubeflow local environment, obviously in the Kubernetes local environment that you are trying to run. So you define the pipeline name, and then you will be uploading the same YAML file. You will again define the, so interface pretty much remain the same because Vertex AI is built on top of Kubeflow. So if you see, there is a similarity between both the UIs, the Kubeflow pipeline UI as well as the Vertex AI pipeline UI. So in this particular case, we'll run like a, instead of like local next 24, so that to make a difference. And then you can, once the model pipeline has been executed, you can view that progress and compare both the logs. And there is option in the UI where you can identify the logs, track those logs and see. So this is a Vertex AI part. We'll see the logs where we'll see it has printed Vertex AI, so hello, next 24. Down there, yeah, next 24. And in the local environment, we'll see it will print hello, local next 24. So the whole messaging behind this is just using one framework, I'm able to make complete MLOps pipeline portable so that I can deploy it either on the local environment or on Vertex AI or any other cloud environment based on my need. Okay, parting thoughts. So obviously these are very complex and you can refer to that. There are a lot of materials available around it if you want to go deep into each elements of it. But this is how the complete pipeline or the MLOps in any ML environment will look like. Obviously the component name will change. But one thing to highlight, if you are new to the MLOps, please include the MLOps model monitoring as well, because that is important to track the performance of model in the production environment. Second thing, the feature store, so that you don't re-engineer the features again and again if that same data set is being used to build a different model for different use case or by a different team. So if you want to try out, just scan this. This will basically give you an overview of the Vertex AI pipeline intro that we have seen so that you can try it out yourself. So I will put it for a minute. Okay. And so what, sorry. Okay. So key thing to remember is think about portability before you build any MLOps pipeline or any solution. Any solution, it can be ML solution or it can be any UI application as well. Second thing is Vertex AI give you a flexibility both of using Vertex AI component as well as open source component. It is also a complete managed service, so that completely offload the ops part. And pipeline that can be used is Kubeflow pipeline or Array. Both are agnostic orchestrators. And the Jang framework is hardware flexible. So because it's built ground up on the OpenXLA, it's compatible with both GPU and TPU. So the model portability, if you are looking for different hardwares or accelerator to run your model, it becomes very easy. And last thing, if you want to share any feedback, please go through our console and send our feedback. Even our engineering team basically tracks your feedback. But if you are looking for any support, please raise a support ticket, because this won't be a right platform. You might not get a quick response on top of that for support related issue. But any feedback, our engineering team is basically tracking that. And If you want to learn what you have learned in Google Cloud in GIDS, please scan this code for special offers. And that's what I wanted to cover. Thank you very much for joining us for this session.